Hello everyone, in this video I am going to discuss about the conversion from CFG to PDA. We are just going to convert the context free grammar to the pushdown automata. Fine. So before converting from CFG to pushdown automata, first we see, like if you take CFG there are 4 tuple notations used, and if you take PDA there are 7 tuple notations are used here, right? So like BTPS or the tuple notations which you have used for what context free grammar. V indicates the variables, T indicates the terminals, P indicates the productions, and S indicates the start symbol. So always the production rule will be given and the input string also will be given. With the help of the production rule, whether the given string is derivable or not, we used to check in the context free grammar, right? So always the context free grammar will be in the form of the production rules. When it comes to PDA, the model we are just going to construct it for the given string. That is what PDA, right? So if you take PDA, there are 7 tuple notations are there. One is Q, which indicates the finite set of states, and sigma indicates a finite set of input symbols, and upper gamma indicates the stack alphabets, sigma del indicates the transition function, q naught indicates the starting state, z naught indicates the final state, and z naught indicates the start symbol, and f indicates the final state. Since it is going to be the acceptance by empty stack, since it is a non-deterministic PDA, always when it comes to conversion we will be just using NPDA. Always the NPDA will be ending up with acceptance by empty stack. Since it is acceptance by empty stack, there is no final state, that is null, right? Now we are just going to convert the CFG into the PDA format now. So before converting from the CFG to PDA format, I am just going to explain you the 4 steps. Only those 4 steps are going to be applicable for the conversion from CFG to PDA. What are all those 4 steps means? The CFG to PDA conversion means the grammar will be given, the production rule will be given. We are just going to convert that into the PDA form, right? So always the grammar will be the given. For example, the given grammar is the start symbol S gives A and B, right? This is the given grammar. Before that, I told you, like, I'm just going to explain you the 4 steps, right? So generally if you take any grammar, the grammar is given and the string is given. Always we are supposed to start with only the start symbol, right? Always will be starting from the start production, right? That is what we used to do in what? The context free grammar, right? The first step is always we are supposed to start with only the start symbol, right? So the first transition is we are supposed to feed the start symbol first of all inside the stack, right? So how the transition function can be written for the start symbol means, for example, since we are just going to convert it into PDA, we are just going to use the stack, right? And the grammar will be given. So initially we are just supposed to, initially there will be the z0 inside the stack. To know that we have reached the end of the stack, we are just putting one element, that is z0 inside the stack, right? Now since we are supposed to start from the start symbol, usually we need to start with the start symbol only, right? So the transition of when you are in the state Q and when the stack top symbol is z0 and there is no input symbol read, it means that we are in the starting state, right? In that case, it's ready to, it means that what, your stack is empty and there is no input to read. It means that it is ready to execute the process. Actually, the whatever the process you want to start, you can start doing it. So Q comma, since all are empty, it's ready to insert the start symbol now. So I'm just going to insert the start symbol on top of what is z0. So when it comes to start symbol, since we always used to start from the start symbol in the CFG, we are supposed to execute this transition function first. And the second step is, now we have pushed the start symbol S inside the stack, right? So when there is the variable on top of the stack, when your stack top element is the variable, you cannot push any terminal on top of the stack, any other alphabet on top of the stack, unless you don't replace it, you won't be able to place any other terminal on top of the variable. So you need to replace the stack. Replace this variable, the start symbol, yes. How this can be replaced? With the help of the right hand side, it can be replaced, right? So how for variables, how we are supposed to write the transition function means, transition of you're in some state that is Q. So since your stack top element is S, you cannot use any input element over here. We are supposed to replace it, right? For example, S gives A, B and A. like that it is having means I have two options for s to if you want to replace this, I have two options, right? One is q comma ab and another one is q comma a, right? Since I have two options for yes, I am showing the two options if it is variables, right? Now I have replaced the variable. Now we are just going to pop the operations out, right? So for all terminals or values or whatever, how we are going to write the transition function means q comma, if your stack top element as well as your input element is same, we are supposed to do the popping operation. This is the third step. Now we have popped out all the elements, like we have input elements as well as all the elements in the stack, we have checked and all are cancelled. Finally so it means that you are in the state q, there is no input element to read as well as there is no stack element inside. It means that there will be only z0. In that case it means what? We have reached a final state. So it can be represented like this, q comma epsilon. So when you check the first and the last, both are same actually. This is going to act as the initial stage. After processing it again, we are just going to reach only this state only. So when you check the flow, like always, since it is non-deterministic pushdown automata, we are just going to consider all the possible options. Only the correct path, the correct options only will be traced out, and that will be considered as the final steps for executing the problem. That will be the considered as the final solution steps, right? So these are the 4 steps you are supposed to follow, right? Now we take one example and we are going to solve that, right? So here the example is S gives A S B and S gives AB. This is the example. I just want to convert the CFG to PDA model, right? Now what we are supposed to do, we are supposed to write a transition function first of all, right? So when we write a transition function, the first transition must be completely about the start symbol, and the second function is about the variable, third function is about the terminal, and fourth function is about the reaching final step, right? The final state, right? Now initially we are just going to convert into the PDA model, right? So if you take the stack, initially there will be only z0, right? So at your initial stage all will be the empty, right? So how it can be written? Transition of, you are in some state that is q, and what we are just going to do, initially it is empty and my stack top element is also z0. In that case what can be done? You are ready to push the start symbol inside the stack, right? So you are in the state q, and after pushing the start symbol yes inside the stack, the status will be s z0, right? So how it can be written? See, if you take CFG, there are 4 tuple notations VTPS. So what are all the variables here? There is only one variable, that is yes. Terminals, there are 2 terminals A and B, and the production, these 2 productions, and the start symbol is yes, right? So if you take PDA, there are 7 tuple notations. One is finite set of state, the final state is q. The input symbols are, all 3 are going to act as an input symbol, yes, A as well as B, or going to act as an input symbol. And then what? A stack alphabets. Our stack alphabet also is going to be S, A, comma, B. All these are stack alphabets. And the fourth indicates what? The transition function. These are the transition functions. And then what? And the next alphabet is Q0, that is initial state, that is Q. Since I am going to use only one state here, my state is Q. And the next one is Z0, the start stack symbol, and this final one is the final state, and the last notation is final state. Since it is acceptance by empty stack, it is going to be the null, right? So the first transition is about pushing the start symbol inside the stack. So initially a stack must be empty, there must not be any input symbol to read. In that case only you will be able to push the start symbol inside the stack, right? And your second transition is transition about what? Variable. Now inside the stack there is a variable. So when there is a variable on top of the stack, you cannot insert any other input element inside the stack. So it is epsilon q, right? So there is no input element, you are just going to replace the variable, which is yes. So if you want to replace the variable yes, you have 2 options. One is ASB, another option is AB. So it can be written as q comma ASB, that is one, this is one option, and the second option is q comma AB. This is the third option, right? This is the second transition. Your third step is about completely for your terminals, right? What are all the terminals we are just going to use here? We have used in the grammar here only A and B. So only according to the CFG to PDA conversion, only the popping operation we are just going to do. So only for the popping alone we are just going to make the transition function, and that too when we will be doing the popping means when your input element as well as when your stack top element is same, then only we will be able to do the popping element, right? Since there is only two terminals over here, for these two terminals alone we are just going to make a function over here, that too for only popping operation. So when we will be able to do the popping operation, you are in some state when your input is A as well as when your stack top element is A, then only you'll be able to do the popping operation, right? Another terminal which we have used in the grammar here is B. So when your input is B and when your stack top element is B, you can do popping operation Q comma epsilon, right? We have inserted a start symbol. If there is a start symbol on top, variable on top, it must be replaced with the option either with ASB or AB. Fine. After replacing it, again if there is a on top, you can replace it yes with the help of this transition function. Suppose that the top element is the terminal, so your input element is also the terminal, you can do the popping operation. Finally everything is done, you are supposed to reach the final state. So when you reach the final state, your stack will be empty. It means that it will be holding only Z0 and there is no input symbol to read. That time you will be reaching the final state, right? So now you can pop out that Z0 also, and you can make your stack completely empty. So only these four transition functions we are just going to use, right? We are going to use to convert the CFG into the PDA model, right? Now we have made the transition function for this grammar. Now what we are just going to do, we are just going to take one grammar, that is which is derivable. We are just going to take one language or a string which can be derivable with the help of the grammar. So shall we take okay, I'm just going to take triple A, triple B, which is with which this string is derivable. The language is derivable with the help of these two grammars, right? So I have taken this example with the help of the transition function. I'm just going to check with the help of this PDA transition function. I'm just going to check whether with the help of this grammar this language is derivable or not, right? So my input is triple A, triple B, right? So initially my stack will be empty. It means that there will be Z0 inside the stack, right? Now see, to check whether it is derivable or not, we always supposed to start with the start symbol. Since my start symbol is S gives ASB or AB, I just want to insert the start symbol only inside the stack, because I am supposed to start with only the start symbol, right? So with the help of the first transition function, I am just going to push my start symbol S inside the stack, right? Now my stack top element is S. If my stack top element is S, what I am supposed to do, I am supposed to replace this S with the help of ASB or AB. According to my language, ASB is the right one to replace this S, right? So in the second step, what I am just going to do, so I'm just going to start with the start symbol which is S. After replacing S, in the place of S, I'm just going to place ASB, right? Now I'm just going to replace this S with ASB. I'm not going to put in this format ASB. First B I'll put inside, second S I'll put inside the stack, and third A will be placed inside the stack. It means that in this order I'm just going to place it inside the stack. Already there was Z0. Since I just want to replace this S with the help of ASB, first B will be pushed inside the stack. After B, S will be placed on top of B. Then again A will be placed on top of A, right? Now I have replaced this S with the help of this A. Now I'm just going to check my stack top element. My stack top element is terminal, right? If it is a terminal as well as your input symbol is also A, you can cancel it, right? So A will be popped out and A and this A will get cancelled, right? Now the stack top element will be what? Yes. Now if your stack top element is S, you cannot insert any new value inside. It means that you are supposed to replace this S with either ASB or AB, right? According to my language, I am supposed to replace this S with what? ASB, because 3 A's are required, right? Only 1 A we have reached, 2 more A's we are supposed to reach, right? So if you substitute AB, only 2 A's will be getting. So ASB is the right choice to replace this S, this top element S, right? So in this this A, I'm just going to cancel it with this A. So finally there will be only SB inside the stack. S is going to act as the top element. I'm just going to replace this S again with what? A, S, B. Already B was there in the previous step, right? Now in the next step, my stack will be, already there was Z0 down and B also was down. In the place of S, I'm just going to replace A, S, B. So B should come first, S second, and third A, right? Now I'm checking the top element. My top element is A. If my top element is A, check your input tape. Your input symbol is also A. If so, A can be cancelled. So popping out. So after popping out, again the top element is what? S. Yeah, that is variable. If it is a variable, you are supposed to implement this transition function, right? Now two A's are cancelled, only one A and one more B's are needed over here, right? So in this case, ASB or AB, if you check, AB is a right choice to apply to replace this S, right? Now already inside the stack there was Z0, already B also there, again another B also were there. Instead of S, I'm just going to place A and B inside the stack. First B will be pushed inside the stack and A will be pushed later, the second, right? Now my top element is A. If the top element is A, check your input element is also A, right? So this A and this A will be popped out, will get cancelled, right? Now the stack top element is B. Use this transition function. My input is BS, my stack top element also BS. Again, the second B will be the stack top element. Check your input. Sorry, extra B I have written here. B. Again the top element is B and your input symbol is B. B got cancelled. So finally there is no input symbol to read, as well as your stack is empty, there is only Z0. So use this transition function, that is Q epsilon Z0. Finally you make this Z0 also empty, and finally your stack is empty. It means that the given language is consumed by the PDA model. So this is how we are supposed to convert CFG to PDA model, right? So if you check, the first step and last step are same, only the right hand side part is different. This is the initial stage and this is the final stage, right? Now how it will compute, how the model will compute means, we are just going to make an instantaneous description for this now. So we are in the state, we are just used only one state, that is Q, and our input is what? Triple A, triple B, and what? Initially inside the stack there will be only Z0, right? And this is the condition. So initially we are supposed to what? We are supposed to insert what? Insert the start symbol only. So this is a stage, we are in some state we have introduced, and this is our input symbol, and initially inside the stack there will be Z0, right? So what will be the initial stage? Initial stage is Q epsilon Z0. This is the initial stage. So we are in some state, there is no input to read, and your stack top symbol is Z0. When it is in this state, then only you can start doing the process actually, right? So this is the condition, this is the given input. To derive this particular language, what are all the steps you are supposed to follow only, I am just explaining now. So this is the initial stage, right? So in this stage what will be done? Either will be pushing the start symbol inside the stack, that can be done, that is number one, and another option is what? We can make this also epsilon. We have two options for this, right? One is we can push start symbol inside the stack, and another option is we can make this Z0 also empty and we can write it as Q comma epsilon. So in that case what will happen? Without doing any process, simply we have deleted and we have reached this state. Actually we have not done any of the process. So this path is not the right one. This is the right path, because we are supposed to start from the start symbol. Since this is the initial stage, we are pushing the start symbol inside the stack, right? So from here only we can proceed. Now the next step is what? So your input is triple A, triple B, and your stack status is now start symbol you have inserted, you have pushed inside the stack. And the next step is what? The next step is it can be replaced. You are supposed to replace A, since it is the variable here, you are supposed to replace it. So when you replace it, your input is your actual input is triple A, triple B. What kind of modification can be done in the stack? This S can be replaced with either ASB or AB, right? ASB, or else it can be replaced with triple A, triple B, AB, right? Now which one is the right one? We need to check. This first A will get popped out. The first A and first A will be popped out, right? Now you need two more more A's and 3 more B's. Here 2 A's and 3 B's here also required, right? But here when you check, only 1 B is available. 2 more A's can't be able to get it if you substitute AB. So AB is not the right choice. You can proceed by here again. So again when you check your stack top element is yes, when it is yes, again you will be getting the two option Q comma your actual after popping out the first A, there will be only 2 A's and 3 B's will be there. Instead of S, what can be done? Either A is B, already B was here, can be substituted, or else the second option is Q comma double A triple B was there inside the input tape, and only A B can be substituted, right? In that case A will get cancelled, here also A will get cancelled. Again 1 A triple B's are required, but according to this one more A cannot be achieved, right? So this is not the right one. You follow this path. So follow this path. So this is how we are supposed to follow. We are supposed to generate the instantaneous description. So based on this, the right path alone will be considered, and that will be considered as the final solution path. So this is how we are supposed to convert from the context free grammar to the PDA model. Thank you.